really difficult for us. Estimating derivatives at a point. If you are given a table and you are asked to estimate a derivative at a point, you need to pick the 2 points closest to it and use that to estimate. So, in this case, our x value is 4. 4 would fall right here. It is not perfectly between 2 and 5, but it is between 2 and 5. So the best we can do from a table is just to give the slope at the points closest to it. We don't want to use the endpoints because that's like average rate of change over the entire thing. But what we want to do is find the rate of change of the points closest to 4. So we're just going to take the point to 11 and 5, 7. And whenever they give you these questions on free response questions, and they do a lot, you're going to say f prime of 4. It's going to say show the work that leads to your answer, which means you need to show that you're doing slope formula. Even though it might be easy enough to do in your head, you've got to show the work where you set it up. So you're going to do like 11 minus 7 over 2 minus 5, or 7 minus 11 over 5 minus 2. Either one of those are okay. Notice I'm using the squiggly equal sign right here. That symbol means approximately. On the FRQs, they don't count off on the real test if you use an equal sign when you shouldn't here, but you really shouldn't use an equal sign because this is an estimate. It's not the exact value of the derivative at that point. So we're going to get 4 over negative 3, so we would want to write this as negative 4 thirds. There. And so the approximate slope of the tangent line at x equals 4 would be negative 4 thirds. Just slope formula, that's all you got to have. Okay, questions? Yes? No, honestly, like if it's free, if it is multiple choice, it's going to look like what I've written. But on a free response, you don't even have to go past here. You can write down 11 minus 7 over 2 minus 5, not do anything else, and you'll get the right answer. So as long as what you have is mathematically correct. So, you know, on these, I don't like to leave it here. I like to go ahead and get the answer, but it's but you could technically leave it right here. All right, so we are supposed to use the graph of g of x to the left to estimate f of 0, f prime of 0, f prime of 6, and f prime of 4. So if you're given a graph and you're estimating, you're thinking about slope of the tangent line. There is a typo on this one. All of those say f, and this says g. So let's change this to an f so that those match, because otherwise you're not really going to be able to answer the question. So at 0, we're looking at this point right here on the graph, and we're thinking about what a tangent line would look like. So, you know, we are estimating right now. So that means that you might not get a perfect answer. So you may get something a little different than what I have. In fact, I feel like that needs to go up a little bit maybe. I almost think it's easier to draw these in like by hand than with this. So if you're estimating slope of a tangent line here, you just want to find the points that are closest to grid lines here. So like that one right there is just about on it. And I'd probably go down here maybe. That's pretty close. Estimate, it'll be fine. All right. So if I want the slope of that line, I'm just going to do rise over run. So I'd have to go down 3 and to the right. How many there? Oh wait, I didn't go down 3. How many did I go down? It's 3 blocks, but look at your scale. It's actually 6. Each one of these blocks is 2, so that's down 6. Let's see, 1, 2, 3, 4, 5, 6, 8 to the right. 8 blocks, which actually, if you do them both wrong, it doesn't matter. But because it just reduces the same, but that'll be 16. So negative 6 over 16, that will reduce to negative 3/8. Technically, you would have been okay if you just counted the blocks, because the scale's the same on both axes, so you'd be all right. But, okay, so that's all we're doing for something like that. At f prime of 6, 6 is going to be right here. So we would be looking for a tangent line at that point. I think it's going to be a little steeper right here. Gosh, that's really not hitting grid lines very good, is it? Drag this on out. Okay, maybe right here down to, I mean, really, it's just about -1, isn't it? It's not quite. Maybe about right here. Let's see, that would be down 16 to the right, 14, so -8/7. Any guess that's close to -1 would probably be a pretty good guess right there. What about at f prime of 4? We got vertical asymptote at 4. Does the function even exist at 4? It does not. So can we have a slope of a tangent line at 4? We cannot. So that would be does not exist. Okay. So this says true or false for all the x's in the domain of f, f prime of x is less than or equal to 0. So what does f prime of x tell us about the graph again? That is the slope of your tangent line. So are the slopes of all my tangent lines going to be negative? Like, if I pick more point, well, there is that point where it does not exist. It is covered by the fact that they say for all x's in the domain of f, because 4 is actually not in the domain of f. So while yet, like if they said for all real numbers, then we would say no, because it does not exist at 4. But because it says all numbers in the domain of f, that sort of excludes 4 for us. So ignoring 4, like if I pick other points, let me erase some of the stuff I got here because it's kind of jumbling up. Definitely I got negative slopes for both of the two I found, right? Like right here, would I have a negative slope? How about over here? Yep. What about up here? Anybody see anywhere where you don't get a negative slope of a tangent line? You should not. This is a true statement. Because this is only asking us if this is true for all x's in the domain of f. 4 is not in the domain of f because it's like a restriction on your domain there. So since 4 is not in the domain, then we're just saying everywhere it does exist, what is the derivative? Does that make sense? Okay, all right, here. All right, these are weird problems, but I think they're good to think about. I'm supposed to fill in all my boxes here with a blank that says greater than, less than, or equal to, but I don't think we actually use equal to right there. So f of -3 minus f of 5 all over 8, -8. Just actually, let's look at b first. Let's look at b first. f of negative 3 minus f of negative 1 over negative 3 minus negative 1. What is that? What are they finding by doing that? What? Not a derivative. More simple than that. Something you could have found even in like Math 1. This right here is just the slope of the line between negative 3, f of negative 3, and negative 1, f of negative 1. So it's just a slope formula. Like those f of negative 3 and f of negative 1, those are y coordinates. And then negative 3 and negative 1 are x coordinates for that. So it is the slope of the line between negative 3. So x equals negative 3 right here. It's that purple dot that I've just colored over in blue so it's not purple anymore. And then this green dot up here is where x equals negative 1. So what we're finding right here is the slope of this line right here. That's the slope of that line. F prime of 3, that's a derivative. That's slope of a tangent line. Where? At 3. So I'm going to do that. I'm going to show that in red. F prime of 3, right here's where x equals 3. Slope of your tangent line would be like this. Okay? Which one is greater? The one on the left, the blue. This blue line is going to have a bigger slope than that red line, right? I don't know how much. I don't need to know. All I need to know is that that should be a greater than sign right there. So let's do C. This is still the same thing, right? This is still the slope of that blue line. Okay? Now we're talking about, let's do this green right here, f prime of negative 1. So f prime of negative 1 would be right there at negative 1. It's the slope of this tangent line. Okay? Which one is steeper there, the blue line or the green line? Which one? Still the blue one, right? Blue one's still steeper. So you would get a greater than sign here. Okay, I didn't ask this question. What if I had said f prime of negative 3? I might have meant to do that. What do you think about that? That purple line's going to be steeper, right, than the blue line. But it didn't actually ask me about that, so I'm going to take that off. So let's go back up here. What in the world is this? Right, I think they've just put the bottom together, right? Because if I did f of negative 3 minus f of 5 over negative 3 minus 5, that would be negative 8 in the bottom, right? So this is just a slope between f of negative 3 and f of 5, which is over here. That's this purple line right here. Okay? What about over here, f of negative 1 minus f of negative 3 all over 2? Actually, I think that's a mistake. No, it's okay. It's okay. It's the same as B and C. It's that blue, because if I did f of negative 1 minus f of negative 3 all over negative 1 minus negative 3, I just get a 2 in the bottom. It's the slope between negative 1 and negative 3. They did the slope backwards. They did the f of negative 1 first instead of f of negative 3. But it's still this blue line right here. So which one is going to be greater there, my blue line or my purple line? Blue. And so the blue's on this side this time, so I'm going to have a less than sign for that. Okay, questions? So you're just looking at graphs like visually for that. If it looks like this, it's a slope formula. If it's a derivative, you're drawing in a tangent line for that. We're going to skip that. All right. Here I have a function f. I need to graph the derivative of f. So this is f of x right here. And I want to graph over here f prime of x. What is f prime? What does it tell us about f? F prime tells you the slope of the tangent line. Right? Now, in this particular case, it's a little bit weird because can you really have a slope of a tangent line here? Like a line that just touches at one point. You can't, because you have a straight line. So if you can't do a tangent line, it's just the slope of that line, right? So what is my slope of this line right here? Let's see it. You count by twos on this graph. I think that's at 1. I think this is it. So this is 1. This is 5. So it would be like the point -2, 5, and 0, 1. So you'd have 5 minus 1 over -2 minus 0. You would get 4 over -2. You get -2. So the slope of that line is -2 everywhere, right? So if the slope of that line is -2 everywhere till you get right to this point, here's what that looks like on this graph. Let's just count by ones here. So I'm going to say it's -1, -2. So that means you're just going to have a horizontal line until you get right here. Okay? But what happens when you go past the vertex of this absolute value graph? What happens over here? It's a positive slope. It's going to be the reflection of that, right? It's going to be +2. So your graph will jump up right here to +2, and you'll just have a straight line. They are going to be both open circles. We'll talk about that more on Monday about why they've got to be for that. But for right now, just take my word for it. Open circles on those. I'm not too concerned with things like that. We'll talk about that more later. Mm-hmm. Oh, you're right. I should go all the way to 2 because I'm counting by ones here. And that scale. Let's go on a little further. Let's go to 2. Let's go to 2 because my scale's not the same on that graph. Thank you for that. So, we are going to look at sketching these graphs roughly just a little bit more on Monday. There was an assignment I had for this, but we're just going to do a few of those problems like as a warm-up Monday. So I'm not going to, we didn't go very far with this, so I don't want to like give you an assignment on it. So